This application question is going to be slightly more tricky because we're using this vocabulary of angle of depression. So when you have an angle of depression, think about something is in the sky, like a plane or birds, and they're looking down on something. So let's just say there's a person in the sky for some reason, looking down on something. Maybe he's on a cliff. That makes more sense. Okay, so he's looking down. Now, if he were to look directly across, you would see that that would be his horizontal line. And then if he looks down, this guy is considered his sight line. The angle of depression is always in between the horizontal, that's left and right, and the sight line. So that's going to be our angle of depression. But what you'll notice is if I have a ground horizontal line, this angle is going to be congruent to this angle because those two angles are alternate interior angles. So that means I can form either this triangle or I can form a different triangle that's the exact same with the exact same measurements down below here. So with that in mind, now we're going to solve this problem. So from a hot air balloon, so here's my hot air balloon, Tulua's measures a 27-degree angle of depression. So think about what's the straight across and angle of depression. So we're looking down at something to a landmark. So there's my landmark. Okay, the angle of depression is 27 degrees. It says that the landmark is 638 feet away, measuring horizontally. So that means that this ground horizontal distance is 638. And it says what's the balloon's vertical distance, so that is the up and down. So knowing the definition of what an angle of depression is, if this is the 27-degree angle, I can also say that this angle on the ground and the hypotenuse is going to be also 27 degrees. So from there, now I'm ready to label my opposite adjacent hypotenuse. X is my opposite, 638 is my adjacent, 27 is my reference angle. So we're using tangent here. So tangent of 27 is equal to x over 638. X is high, so we're multiplying 638 times the tangent of 27. So I plug that into my calculator. And that gives me that the x value, or the vertical height of the balloon, is 325.1.